Now we are going to study question from October 2012 exam, question 3. Everyone give the heading, October 2012 exam, question 3. This question is little bit tricky question, guys. Here we are going to learn lot of things. So try to see the scenario here. Now what they mentioned in the question, an overhead camshaft wall moves with simple harmonic motion. So here camshaft wall is moving with simple harmonic motion, camshaft wall. The wall lift is how much? Guys see, lift, stroke, travel, all are the same things. So wall lift is how much? How much lift they have given us? Wall lift. Wall lift is how much they have given us? 40 mm. 40 mm means what? 0.04 meter. 0.04 meter. So from wall lift what we are going to calculate? From wall lift what we are going to calculate? We are going to calculate R. So R is equal to, what is meant by R, everyone? R means what? Our amplitude of SH. So lift by 2. So lift by 2 means what? 0.02 meter. Okay, everyone getting my point? Try to see the scenario here. Now wall is opened and closed. See the point. This point is very important. Underline this point. Wall is opened and closed within a 120 degree of camshaft rotation. See the point here. Wall is opened and closed within a 120 degree of camshaft rotation. So wall is opened and closed. What, guys? Wall is opened and closed within 120 degree. Okay, I will explain you what is the meaning of this sentence. 120 degree of camshaft rotation. 120 degree of camshaft rotation. I will explain you what is the meaning of this sentence, guys. So don't worry. Now the mass of the wall is how much? How much mass they have given us? Mass of the wall is what? How much mass of the wall? M is equal to what? 0.8 kg. M is equal to what? 0.8 kg. The wall moves against a spring and the maximum and minimum spring forces are 900 Newton and 180 Newton. So SF max, maximum spring force, SF max is how much? 900 Newton. And SF minimum, everyone, SF minimum will be equal to what? 180 Newton. See the point here. Okay, 180 Newton. The camshaft speed, which speed? Camshaft speed. So here N camshaft, N camshaft is equal to what? How much is the N camshaft? 480 revolution per minute. Okay, everyone getting my point? Try to see the scenario here. N camshaft. So first of all, guys, before going further, first of all write down these given things. Everyone please write down all these given things, then we will see further things. Now try to see the scenario here. See here, there is a few twists in this question. First twist is what? See this one. Wall is opened and closed for the what? 120 degree of camshaft rotation. Means for 120 degree, guys, when camshaft is rotated by 360 degree, out of 360 degree, one open and close. Like I see, open and close. What is the meaning of open and close? One cycle of the wall. Okay, so wall is open and closed within a 120 degree. Means for the 360 degree, out of 360 degree of camshaft, wall is opened and closed for the 120 degree only. Try to see the point here. Now here they have given us N camshaft. So omega camshaft will be equal to what, guys? Omega camshaft. This is a camshaft, everyone. Omega camshaft will be equal to what? 2 pi N camshaft. Try to see the scenario here. 2 pi N camshaft divided by what? 60. So 2 pi n camshaft is how much, everyone? How much is the value of n camshaft? 480 divided by 60. So everyone, please do the calculation with me and try to tell me the value of omega camshaft. Very simple discussion, guys, not that much difficult, but there is a twist in this question. So 2 pi. So please do the calculation. 2 pi into 480 divided by what? 60. How much? 50.2655. How much? Radian per second. Okay guys, are you getting my point? So here we got the omega camshaft. Try to see the scenario. Means angular acceleration, means angular velocity for omega camshaft. Okay. Now omega camshaft will be equal to what? Another expression for omega camshaft is equal to what? 2 pi by tau camshaft. Everyone getting my point? Try to see the scenario here. Means 2 pi means what? 360 degree, and tau camshaft means what? Time required for one rotation. Means for the 360 degree. Means see, we have seen, guys, tau means what? Time period. So for one cycle, means here one cycle of camshaft means was one rotation. Try to see the scenario here. So omega camshaft will be equal to what? So now tau camshaft will be equal to what, everyone? Tau camshaft means time required for one rotation. What is the meaning of tau camshaft, guys? What is the meaning of tau camshaft here? Here for our understanding, I am going to write down the meaning of tau camshaft, or where try to see the scenario here, where okay, tau camshaft means what? What is the meaning of tau camshaft, guys? Time required for one rotation of what? Camshaft, guys. Time required for one rotation of camshaft. Okay. So here tau camshaft. So therefore tau camshaft will be equal to what? How to get tau camshaft, guys? Tau camshaft is equal to what? 2 pi by what? Omega camshaft. Try to see the scenario here. Very simple discussion. Not simple, a little bit twisted, but little twist. Not that much difficult, guys. So 2 pi omega camshaft we just now calculated here. 50.2655. 50.2655. So tau camshaft will be equal to what? Tau camshaft will be equal to what? 2 pi 50.2655. How much value we are getting? 0.125 second. Okay. So for one rotation of camshaft, how much time we required, guys? For one rotation of camshaft, how much time we required? We required 0.125 second. How much time we required? 0.125 second. Okay. Anyone have any doubt in this discussion? Try to understand the point. So now here they mentioned, guys, whenever for wall is opened and closed within a 120 degree of camshaft rotation, means whenever we have a 360 degree of camshaft rotation, out of only for the 120 degree, in only 120 degree wall is opened and closed. So means wall open and closed means what, guys? Wall open and closed means what? What is the meaning of open and closed? One complete oscillation or one complete cycle of the wall. Guys, here I am not saying rotation, because wall motions is okay, reciprocating type. Okay, so one complete cycle, top to bottom and again bottom to top, wall is open and closed. Try to see the point. Wall is open and closed within a 120 degree. So out of 360 degree in 120 degree. So this much time is required for 360 degree. So then how much time will be required for? So therefore tau. Okay. So tau SHM. Guys, who is following here SHM? Who is following here SHM? Wall is following SHM. So tau SHM means what? Time period for SHM. Tau SHM will be equal to what? Time required for one complete oscillation of wall will be equal to what? So this time is for 360 degree, but we need a time for what? 120 degree only, because in 120 degree our wall do its complete one oscillation. Guys, I am saying one oscillation, I am not saying one rotation, because our wall moving up and down like that. Okay, try to see the point here. So tau SHM, try to see the point here. So tau SHM will be equal to what? So this is for 360 degree. So how much time we require for 1 degree? 0.125. Okay, so here see, this time is for 360 degree. How much time we require? 0.125 second. So for 1 degree, how much time required, guys? How much time required for 1 degree? 0.125 divided by 360 degree. Then how much time we required for 120 degree? How much time we required, guys? 0.125 divided by 360 multiplied by what? 120. Any doubt in this? This is for 1 degree. So whatever the time we required, so this much time. Any doubt in this discussion, guys? So therefore our tau SHM will be equal to what? SHM means what? For one complete oscillation for the what, guys? Wall. Okay, so that will be what? This 0.125. Anyone have any doubt in this discussion? This 0.125 divided by 360 multiplied by 120 degree. So tau SHM will be equal to what? Any doubt? Please everyone try to see the scenario here. Any doubt in this expression, guys? Tau SHM means one complete oscillation for the wall. Okay, because our wall is following. See here, camshaft is not in SHM. See, in previous questions our camshaft, okay, camshaft and piston, they are moving together. There is a relation there, but here some lag is there. Okay, not complete one. Okay, out there 360 degree, both are related with each other. Here only for the 120 degree. Try to see the point here. So 0. What everyone? 0.125 multiplied by 120 divided by what? 360. How much time we required, guys? Tau SHM 0.04167 second. So therefore omega SHM will be equal to what? 2 pi, that our reference circle diagram. 2 pi for that reference circle, and divided by what? Tau SHM. So 2 pi divided by what? 0.04167. Any doubt in this discussion, guys? Any doubt in this discussion? Please everyone observe this scenario. Any doubt here? Okay, good. So therefore please everyone do the calculation for omega SHM with me and tell me the value of omega SHM. Two pi divided by what? 0.04167. Okay, how much we are getting? 150.7843 unit radian per second. Okay, everyone getting my point? And then in A part, what they ask us in A part, guys? Just observe the A part. What they ask us in A part? Maximum velocity. See, what is meant by maximum velocity? Omega into r. In B part, what they ask us? Maximum acceleration. Maximum acceleration means what? Omega square r. So once we got omega SHM, from omega SHM we can easily calculate our velocity, maximum velocity and maximum acceleration. Very simple scenario. Any doubt in this discussion, guys? So here don't consider this omega camshaft is a omega SHM. Here camshaft and our wall is not, both are not moving together, guys. There is only for the 120 degree of that one. But in earlier question, camshaft and our piston both are rotated, moving together. Here also relation is there, but for 360 degree, means whenever there is a 360 degree, then there was a complete one oscillation of piston in the previous question. But here For the 360 degree, out of 360 degree, only for 120 degree, there is one complete oscillation of our wall here. Okay, see the point here. Everyone getting my point? Discussion. So try to see the scenario here. So before going further, first of all, guys, okay, we have written up to tau omega camshaft, na guys? Okay, now please write down all this point. This discussion is important to us. Now what they have asked us here in A part, guys, in A part they ask us maximum velocity of the wall. Okay, in A part what they ask us, maximum velocity of the wall. In A part our target is what? We have to find out Vmax. And for Vmax, guys, Vmax is equal to what? What is the relation for Vmax? We studied Vmax is equal to what? Omega into R. So Vmax is equal to how much? Omega. Which omega we have to consider here? Maximum velocity. Okay, omega SHM. So omega SHM is what here? See, just now here I have written for my reference. So omega SHM and omega camshaft. We have 2 omega. Out of that we have to consider omega SHM. That wall, camshaft wall. Okay, not of camshaft, guys. So omega SHM is what? 150.7843 into R. R is how much? 0.02. So what will be the value of Vmax, guys? Everyone, what will be the value of Vmax? Maximum velocity. So 150.7843. 150.7843 multiplied by 0.02. How much value we are getting? 3.057 meter per second. Okay, so in this way we got what? Maximum velocity. Now in B part what they are asking us, guys? In B part they are asking us maximum acceleration. Okay, and what is the relation for maximum acceleration? A max will be equal to what, everyone? Omega square into R. So A max will be equal to what? Omega square is what? 150.7843 square into R is what? 0.02. Okay, so what will be the value of maximum acceleration? What will be the value of maximum acceleration? A max will be equal to what, guys? Everyone, please do the calculation with me. Don't forget a square here. So 150.7843 square multiplied by 0.02. How much value we are getting, everyone? 454.7181 unit meter per second square, because it is an acceleration. Okay, anyone have any doubt in this discussion, guys? Very simple scenario. Only twist is what? To get the omega SHM. After getting omega SHM, then A and B part is very easy. So please everyone complete A and B part. Now try to see the scenario here. For the C part, what they are asking us? The force between the wall and cam. Okay, when the wall starts to open, guys, try to see the scenario here. In C part, what they are asking us? Force. Okay, we have to find out force. We will give that name of the force. We will say F1. F1 for what? When wall starts to open. Guys, see the point here. When wall starts to open. When wall starts to open. Guys, when wall starts to open, what will be the position of wall? Top position or bottom position, guys? When wall starts to open, what will be the position of the wall? Wall will be at top position. Try to see the scenario. When wall starts to open, wall position of the wall will be what? Top position. Guys, any doubt in this discussion? So here I am going to draw one drawing here. Try to see the scenario here. Very simple drawing. Okay, just I am going to draw one schematic diagram of the wall. Suppose this is what, a wall. Just guys imagine this is what, a wall. 1 minute, guys, this drawing is little bit just little bit complicated, not that much difficult once you understand the drawing. So suppose this is what a wall, this is what a wall, guys. Okay, everyone try to see the scenario here. This is what a suppose cylinder head. Just observe the things here. Very simple discussion, not that much difficult. Okay, this is suppose cylinder, this is what a wall. Okay, now here there will be what? There will be what? This is what a spring. Try to see the point here. This is what a spring. Okay, little bit. This is what a spring. Okay, guys, try to observe the scenario here. So whenever, guys, see, when wall starts to open, so this is what our camshaft. Okay, try to see the scenario. This is what our camshaft. So we have to find out what we have to find out. Force between the wall and cam. Okay, what they are actually asking. The force between the wall and the cam when the wall starts to open. Okay, what they are asking us. Force between the wall and cam when the wall starts to open. Guys, you see the point. When wall starts to open. Wall starts to open means what, guys? Wall starts to open means what? Okay, it try to open. So when wall try to open, what will be the compression of spring, guys? Maximum compression or minimum compression? See, no, it is, see, maximum or minimum? Why it is maximum? If it is maximum, why maximum? If it is minimum, why minimum? Guys, at the start, guys, see, when wall starts to open means what? It is compression of the spring is minimum. When wall fully open, then compression is the maximum. Now, guys, see the scenario here. It is a little bit practical scenario here. So here, and spring force is always opposing the motion. Okay, so it is try to go down. Okay, so spring force will be what here? How the spring force will what act? How the spring force will act, guys, everyone? Opposite. So this will be what? Our spring force will be equal to what? Here spring force will be equal to what? SF minimum. Okay, spring force will be equal to what? SF minimum. Then there will be force, we will say a force, that is what we have to calculate, force F1. And there will be what? They have given us a mass of the wall. How much mass of the wall they have given us? 0.8 kg. So due to that 0.8 kilogram of mass, there will be weight. How much will be the weight? 0.8 g. So weight, how weight will act? Weight will act vertically downward. So this weight will be what? 0.8. How much is weight? 0.8 g, guys. Okay, everyone getting my point? Try to understand the scenario here. So this is what? Yep, any doubt in this discussion, guys? And now this position of this wall is in this scenario. Wall, where will be the position of the wall? Wall is at what? Top position. For this, when wall starts to open, for this scenario, position of the wall is what? Top. With respect to top, fixed point will be where? Fixed point will be bottom. So where will be the direction of acceleration here? Position of the wall is what? At top. Guys, see. Suppose this is a, this is what a fixed point. This is what our top point. Okay. So here wall is what? This wall is at what? Top point. Okay. This is just a line diagram. So with respect to top, fixed point is where? Below. So where will be the direction of acceleration, guys? Where will be the direction of acceleration? Acceleration downward. Okay. Everyone getting the point? So here direction of acceleration is what? Acceleration is what? Downward. And here as it is at top, at the top or bottom, A will be equal to what? A max. A will be equal to what, guys? A max. Try to see the point here. So now, any doubt in this drawing, guys? Any doubt in this acceleration? Please try to see the scenario here. So by our favorite thing, most favorite thing of mechanics, by Newton's what guys? By Newton's second law of what? Motion. Okay, by Newton's second law of motion. What will be the scenario? Summation of what? Summation of force is equal to what? Mass into acceleration. Okay guys, so what is the forces here? Forces in the direction of acceleration. First of all, we will say this force, we will say F1. What we will give name? F1. That is what our target, force between the wall and cam. F1 minus what? Sorry, plus 0.8 g. Then minus SF minimum is equal to what? 0.8. Acceleration is what? A max. Okay. So what will be the F1 is equal to what, everyone? 0.8 into A max minus 0.8 g minus SF minimum. Try to see the scenario here. Huh? So F1 will be equal to what guys? F1 will be equal to what? What will be the F1, everyone? Please do the calculation. So first of all, before doing the calculation, 0.8 A max will be equal to what? What will be the value of A max? We calculated guys in A part. How much value of A max? Maximum acceleration 454.718 minus 0.8, 9.81. See here, this must be plus 9.81 plus SF minimum is how much guys? SF minimum is how much they have given us in the question? 180 Newton. Okay, so please everyone do the calculation and try to find out the F1. Okay, everyone please do the calculation with me. 0.8 everyone please. 0.8 into 454 point how much? 718 minus 0.8 into 9.81 plus what guys? 180. How much value we are getting? 535 point how much guys? 535.9264 Newton. Okay, so in this way what we got guys? We got the F1. Okay, so this will be what our answer of what? Answer of our C part. Okay, force between the wall and the cam. What they ask us in C part? Force between the wall. This is what our wall. This is what a cam. So how much force between them is what? F1, and this is what our target F1. Force between the wall and cam when the wall starts to open. Wall starts to open means its stop position. Okay, anyone have any doubt in this discussion guys? Everyone? Okay, so please guys, everyone. So now how to write down these things? First of all, target, guys, always write down the target first of all. Then this drawing. After this drawing, beside the drawing or below the drawing guys, if you have big drawing, big notebook, okay, larger size notebook, drawing, and then these calculations. If you have smaller size notebook, drawing, and then below that, but it must be look nice, guys. Drawing must be in nice way. Please everyone complete this point. Now what they are asking us in the D part guys? The force between the wall and the cam when the wall is fully open, guys. So here we will say this force in this scenario, we will say this force as a F2 when in this say wall starts to open, when the wall is fully open, guys. So see the point here, wall is fully open. So when wall is fully open, try to see the point here. When the wall is fully open, when the wall is fully open, try see again. We are going to see this is what our wall. Okay, here I am going to draw the drawing of wall. This is what a wall. Very simple scenario guys, not that much difficult. This is what a wall. Here I am showing just this is a schematic drawing. Just I am showing wall is opened here. Okay, so that's why a little bit like this scenario. So wall is opened here. So as wall is opened, spring compression will be more here. Okay. See, as compared to this drawing, guys, see the spring compression. Now here there will be what? This will be what? Our cam. So this will be what? Our cam. So this cam will apply force F2 on the wall. Then there will be what? A weight. How much is the value of weight, everyone? How much is the value of weight? 0.8 G. And then there will be what? Spring force. In this scenario, what will be the value of spring force, guys? In this scenario, what will be the value of spring force? SF max. Okay. And here see, when wall fully open, what will be the position of the wall, guys? At the top or bottom? At the top or bottom, guys? What will be the position? Bottom. When wall is open, at the bottommost position. So bottommost, when it is at bottommost position, what will be the direction of acceleration, guys? What will be the direction of acceleration? Upward or downward? With respect to bottom, guys, see, this is what a bottom position. With respect to bottom, fixed point will be what? Above. This is what a fixed point. So with respect to bottom position, fixed point or midpoint or mid-stroke. So with respect to bottom, fixed point is above. So, and we discuss, guys, acceleration is always directed towards fixed point. So here, so how will be the direction here, everyone? How will be the direction of acceleration? Acceleration must be what? Okay, upward, guys, towards fixed point. Okay, so and acceleration will be equal to what? Here, A will be equal to what? A max, because bottommost point. Now our most favorite thing, by what? Newton's second law of what, guys? By Newton's second law of motion. What is meant by Newton's second law of motion? Summation of forces is equal to what? Mass into acceleration. Summation of forces is equal to what? Mass into acceleration. Okay, what are the forces here? F2 plus 0.8 G. Is it correct or wrong, guys? Is it correct or wrong? Wrong. Okay, so forces in the direction of acceleration considered as positive. And which force here positive? SF max. SF max, because it is in the direction of acceleration, because acceleration is upward, because our position of wall is bottommost, and with respect to bottom, fixed point is above. So acceleration is directed towards fixed point. Try to see the point here. So SF max minus F2 minus 0.8 G is equal to what? Mass is what? How much value of mass? 0.8. Acceleration is what? A max. So SF max will be equal to what, everyone? SF max will be equal to what? 0.8 A max plus F2 plus 0.8 G. Okay. So, sorry. What is our target? What is our target, guys? F2 is our target. So never forget our target. So lot of times, so I may forget target, but you don't have. So 0.8 A max minus, so our target is what? F2. So F2 will be equal to what? SF max minus 0.8 G minus 0.8 A max. Is it okay, guys? Mathematically check it. F2, I've shifted this side. 0.8 A max. Okay, correct. So SF max is how much? How much is the value of SF max, guys? In the question, how much SF max here? 900 minus 0.8 into 9.81 minus 0.8. A max is how much we calculated? How much A max? 454.718. Okay. So F2 will be equal to what? F2 will be equal to what? So 900 minus 0.8 into 9.81 minus 0.8 into what? 454.718. 718. How much value we are getting, everyone? 528.3776 unit Newton. Okay guys, are you getting my point? Try to understand the scenario here. Very simple discussion. So in this way we got the value of F. Okay, please guys complete this one.